Hi guys, and welcome back to another CATIA V5 tutorial. This one's focusing on a assembly or product design, so creating an assembly from scratch using standalone parts. It kind of follows on from a previous video which is on positioning parts within an assembly. So if you haven't seen that, please do go check it out. It might give you a good few pointers for this. So we're in product design now, so if you just go start, mechanical design and assembly design, it'll bring up this view here. You can see the toolbars are completely different. So what you will do is when you have already made parts, so we're going to be using parts that have already been designed, and they'll be the parts I showed you how to design in the first few videos. So what I'm going to do is I'm going to right click on my top node, go to components, and go to existing component. Now you can use it exactly the same over here. You'll see the icon exactly the same. I find though that using right clicking on the actual node on the tree basically makes it a little bit less risky that you're going to choose something that you don't need to choose, essentially, because what you have selected can actually make a big difference in where it goes. So I'm going to choose existing component here. It'll bring up the dialog box that you need. So in this case, I'm going to choose my A-frame, bring it in, bang, it's already popped in. So it pops in as normal. You can see the A-frame part is under the tree. You can open it up and you'll see all the bits it was made from, and you can actually go into it itself by double clicking on the top bit, and you can edit the parts individually within assembly design. Now when you're in assembly design like this, and if you are editing parts, just be wary of where you are within the tree, because then if you start thinking, okay, where are all my things for assembly gone, or vice versa, just make sure your essentially in-work object is selected as the actual assembly. So if you choose one or the other, you'll see the box goes blue and your workbench changes accordingly. So just be wary of that, because it can cause problems. So that's now in. What I'm going to do is I'm going to then right click again, go to components, and go to existing component and choose my strut. And there we have the strut. So you can see immediately that it's what CATIA does is where the origin of the part is, it will throw it in to the origin of the assembly. So the origin of assembly will be exactly the same, and you can see here that the A-frame axis system is exactly the same as the strut axis system, so it will put the parts in at the origin. So as you can kind of see, we don't want it to be there. What I'm going to do is I'm going to basically constrain it so it will pop into this slot here. So as I kind of said in the introduction, this is where the compass comes in on its own, really. So if you want to move a part, obviously you can't just drag it. Unfortunately, it doesn't let you drag it. The best thing to do is to use the compass. So by using the compass, if you set the little red dots, you get the crosshairs on it, drag it, and what you'll see now is it will try and stick to the component. So you put it on a flat surface is best, and you can see now that it's gone green. It's gone bright green, the strut is selected, and now what you can do is you can manipulate that part. If you double click on what you want to choose, so you can see the way it works with axis systems, you can rotate it, you can pull it along a direction, you can pull it along a plane. If you double click on it, you can actually choose to move it in a specific way if you really want to. So you can choose rotational increments, translational increments, or you can even choose a coordinates you want to move to. Now you can use that if you want to be very, very specific. I generally use it so you've got geometric constraints on it instead. So that's how you will manipulate it. You can also use, there is over in the right hand side, a manipulations toolbar, which is down up here. So you can use manipulation as well. So you can choose a part and you can drag it, for example, along Y or Z, and that'll drag it along whatever you choose. You can choose your own axis system using it. So I would suggest you have a play with this particular part, but it's the best thing to use in terms of manipulating a part. I find the compass works best and it's much, much easier. So now we've moved it about, we can start adding constraints to it. So this is a lot like when you're using part constraints. So we're now here. If I want to, for example, get this head here aligned with this hole here, what I can start using is the constraints toolbar, which is this one over here. So you've got many constraints. It's very, very similar to the constraints dialog box in sketching. So you have coincidence, you've got contact, offset, angle, fix together, and several others as well. So when you're actually in an assembly, the first thing I would recommend you do is choose a part to fix. At the moment, these two parts are free in space, nothing basically holding them together. So what I would normally do is choose the A-frame or whatever, doesn't really matter, and fix it. And you see down the bottom what it's done is it's created a constraints toolbar, and you can see the fix is in here for the frame. And what fix does, it basically says that you cannot move this. This is solid in space, that is not going to move. Even if you drag it, it won't move at all. Now this is fixed, what it will mean is it basically creates a datum for your assembly. So if I wanted to add something to it, we know that that's not going to move and this will. So to then create, if I want to create a hole which is coincidence to another hole, all you need to do is click the coincidence button. So this will always come up. I always click that to make sure it doesn't come up in the future, because otherwise it gets very annoying. There's no dialog box for it. It assumes what you're doing is just choosing components on here. And you see what I'm doing now is you'll see axis systems coming up basically saying, do you want to select this? So if you select a cylinder with constraints up, it will select the axis system of that cylinder. So I'll select that. It goes orange to say that I've selected it. And then I'll select the cylinder of this one as well. Click that. And now you'll see that the coincidence constraint has been made. It's in the tree, and it's currently been made. Now you'll see it's currently dark, which means it hasn't been updated. You'll also see next to the symbol here the little update symbol, which means it needs to be updated. So you click update, and you see that it is now moved. So it's moved. The constraints have gone green to show that it is actually now active, essentially. And that's exactly what we want it to be. So it's now in line with that hole. So we also want it to be in line as well. So with the surface, exactly the same again, you do a contact constraint. So with a contact constraint, exactly the same again, you'll choose a surface. You have to choose a surface, otherwise it won't come up. I can't choose for that, for example, I can choose it, but it won't work. Choose a flat face and another flat face, and you'll see again what it's come up as it's worked. It's not active, so press update, and there we have it. But as you can see, this particular part hasn't been correctly made in a way that will allow me to essentially use this. So what I can do is, as I was showing in the previous episode, is I can then go ahead and edit this if I need to. So what I want to do is I want to make this pretty much the same size as that. So what the first thing I'm going to do is measure it. So by using the measure tool here, the measure tool comes into its own pretty much in assembly design. So I can measure between. This dialog box will come up. You have different selection modes. So you can choose points only, edges only. You can choose any geometry. I choose that generally, unless it's very, very picky, you can just choose any geometry only. So the distance between there and there is 30 mil. So press OK. That measurement will stay there. So what I'm now going to do is I'm going to go into my strut. I'm going to go into double click it, and you'll see now I am now within a part design. So I'm within assembly, of course, but I'm within part design of my assembly. So what I'm going to do is I'm going to find the bit I need to change. So set to graph, this split here. So I've got two splits on my either side, and I want to basically make them so it's 15 millimeters either side. So my splits are off of my planes. So find this plane here, 15 millimeters, okay. And then my other plane, I'm going to change to 15 millimeters. Now I've changed that, and you can see already that it's perfectly aligned what I need it to be. And that's just an example then of how you can use the assembly features to edit your parts so that they're exactly right. And now you can see that there's a perfect contact between those two. So we now have a contact and a surface constraint on our A-frame and our strat, which is what we want it to be. But it's not actually fully constrained. So when it comes to things like this, what you can do is do manipulation. But you can do a manipulation in respect to constraints. So what I mean by this is if I move this, it won't, without respect to constraints, or just move it willy-nilly as such. If I move it with respect to constraints, what it won't let me do is it will basically rotate, as you can kind of see there. So what it's doing is it knows the constraints here is a surface and a coincidence, but there's no rotational constraint. So this is very useful if for example you've got a moving part like a piston, and you want to see how it works within the design itself, and you can use this to see how it does work without having to use kinematics. So it will also work. You can choose, for example, your own direction, or you can choose your own axis. So you can choose, for example, that axis and rotate it around that, and you'll see it works much better. And knowing that is quite useful because, like I said, it will allow you to test assemblies if they are moving parts. So if I want to, let's say, put a angle constraint on this, then I have the angle constraint. I can choose the axis going up the shaft, and I will choose the lower floor of this A in order to put it. So with angles, you do get a constraints dialog box because it allows you to actually put a different constraint such as parallelism, perpendicularity, or indeed an angle. Now, with this, you can also choose different sectors. So at the moment, you can see it's choosing this sector of the angle. You can choose different sectors depending on what angle you like. So this angle is the one you like. You can move it so it goes the other way like that. Let's say just choose 45 degrees. And there we have it. So I'll update that now. And you can see sometimes it does do that, but it's now all green. So exactly the same way as we have it in our sketches. When it's all green, that means we know that the constraints are currently active and currently representing what we actually want. Now to show you some other things, what I'm going to do now is I'm basically going to connect this to another wireframe which is on, let's say, a perpendicular side. But instead of having to go all the way in and going insert component, what I'm going to do is quite simply right click, copy it, and paste it. Now when you do paste it, make sure you paste it into the top node assembly. If you paste it into here, it will not work. It says it does not have valid type. You need to paste it within the frame assembly itself, and make sure the frame assembly is activated like this. So right click and paste, and then we have another A-frame. Now the A-frame itself, you won't see it because it's exactly where it is at the moment. So we need to move it. Easiest way to move it is using the compass. Now when you use the compass and it goes green like this, what you can actually do is select, if it's green, anything else. So you can see at the moment the A-frame is selected, the one we want, but we could choose the strut. And if we then moved anything, it would move the strut instead. Now remember I was using the manipulate one. You can see now it will manipulate it with the compass, but as soon as I click update, it will pop it back to where it needs to be. So in this case, I'll move it again with the compass, choose the A-frame, good-o. So I'm going to move that out like that, but what I'm going to show you is an alternative way of defining this particular strut here. So I'm going to go ahead and delete this constraint, this angle constraint here, delete that. And what I'm going to do is I'm just going to use the position of this to define the angle of that. So I'm going to just roughly place this new A-frame here in line with the strut. It basically just makes sure that CATIA doesn't have a bit of a hissy fit and kind of gets it all mixed up really. So what I'm going to do is I'm going to define an offset for this. So I'm going to offset this plane here from this axis system here, and because that's fixed, it won't move. So let's say call it roughly, I don't know, 150 mil. What happens there? Okay, update. It goes that way. So of course you can then just go minus 150 mil, because obviously it's from the dating point itself. So that's not nearly enough, but it still will work. So if I was to define that as an offset, and then go to constraint, and because I'm defining this afterwards, the constraint is going to basically be a slave to the offset. So update it, and you'll see that's moved up in order to satisfy this length here. So if I move this again, if I say, let's say, I don't know, minus 400 mil, click update, it will move everything in relation to it. So CATIA will update each constraint in order to make the new assembly. So that's kind of all of them really gone through. The main ones you're going to be using really is coincidence constraint, contact constraint, and offset constraint. Now, assembly design offers quite a few other features which are quite useful. I've shown you the manipulation one, but there's one or two others as well. Now, what I'm going to do is I'm going to just offset this particular bit right now. So I'm going to move this A-frame that way a tiny bit. And because it's not constrained, it doesn't need to update. So that's as it is now. And there's a tool in assembly design called clash detection. It's this button here. And what this will allow you to do is it's really useful, especially on big components, is a way of making sure or understanding how everything's working. So this is the dialog box will come open. So what it's saying is detect clash. So what type, you can choose contact and clash, clearance, contact and clash, or authorized penetration. So you can see basically what's going on. You can choose all components, or you can choose a selection, for example, but normally it's between all components. If you click apply, what it will do is it will analyze it. So you can see here it's come up as a list, it's come up as a what type, a contact. So there's a contact, it will note it in here, and you can zoom in here. So you can see currently there's a contact between this face here, which you can kind of imagine, and this face here. So they're all sort of contacted together because they're exact same size. However, if you go down like this, you'll see there's a clash, which is being made by the fact that I've moved my part out a little bit. So what it's showing is there's a clash between this surface here and that surface there, and the clash is 49.5 millimeters. And if you've got a really big component, this can be pretty much a lifesaver. You can see it's gone as a kind of traffic light, so it's red, i.e. there are clashes. There is a way of saying that you're allowed to have a certain amount of clash, and you can also choose it as well, so you can have it as clearance. So you can reapply it, and it will show you clearances as well. So that's a great little tool. It's quite intuitive, so you can pretty much go through everything you kind of want, select what you need, and for example change different parameters, and it's really a very useful tool for making sure that your assemblies are correctly made. So in addition to that, I'm just going to hide my constraints to make it a bit neater. In addition to that as well, there's also the sectioning tool. So this will bring up a brand new part, as you can see here. So what I've got, if I go to tile vertically, it will give me two separate windows. So what I've got on my left here is the assembly which I've just done, and what I've got on my right is the section that's created. So what it's gone and done is it's created a plane, through my part, and the resultant plane, if you were section it, is this one here. And what you can do is zoom in, you can have a look around, and you can see what's going on. So as you kind of imagine, you can change it as well. So you've got what's similar to the compass, you can drag, and it will in real time change the sectioning of it. It's a bit like an MRI, I suppose, and now you can see it kind of changing before your eyes. So you can change it, you can zoom in and out, you can rotate it, and you can pan as well. But what you can also do, instead of having a separate window, you can have what's called a volume cut. So what this will do is actually get rid of this one here, or you don't have to use that one, and it will actually just show you what it's cut like within the actual volume itself. And if you were to press OK at this point, what it would do is it would actually physically leave that alone, so you'd have that as a section. So you can use that and create pictures from it, put it into PowerPoint, for example, and that goes under your applications. So it will take a section, and that is essentially on its own. So you can hide the rest of these things here, but your section will still remain. So it's almost like a separate part within your assembly. Going back to it though, you've also got several other options which can be used. So the positioning, so you can position it using like a normal constraint. So you can position it through selections, like a geometrical target. So if I choose that, for example, and choose, let's say, this plane here, or for example, choosing that plane there, then it will select that as the plane to choose. And that's just another one of the little tools you can use. So I'm just gonna get rid of that for now, have it fall back on. Another tool that could be used as well is the explode tool. So what this will do is essentially, like it says on the tin really, is create an exploded view. So again, this can be quite a cool thing to do on, for example, an engine, because you've got lots of different parts and it will explode it out. You can define it as the top level, or you can define it as a subcomponent if you have a sub-assembly. But if you press apply, what it will do is it will explode it out. And what you can do now is you can change it, so you can change the amount of explosion you want on it, and generally it will move it about either in a same plane, or it'll move it in its own separate reference frame. But again, another one of those things which you can kind of have it just have a play around with it. So for example, 2D will move it only in a 2D plane, 3D will move it in a 3D plane, etc, etc. You can also choose a fixed product, so again, choose that one. It won't move, or it shouldn't move. Press apply, and now it won't move, like so. So again, a really useful little tool to have. Finally then, what I'll show you is the snap function. So the snap function is really useful if, for example, you have a CGR. So CGR isn't a cat part file, but you can get it when it gets converted, let's say, from a SolidWorks file. You don't have any of this inbuilt reference systems, for example, axis systems like that. So what you can do is you can just use the snap, and what it will do is you choose one thing, choose another, and what CATIA will do is it will immediately snap it together. So if I was to choose, for example, this axis system here and this axis system here, bam, it's gone, it's hidden away, it's gone exactly the same position as that other A-frame. So press Ctrl Z, get it back. Oh, hello. But it works as well for surfaces, so I can connect that surface and snap it to that one there. Again, you get this sort of immediate snapping feature. Of course, because it's been constrained, as soon as I click update, it'll pop straight back there. But if you have a CGR or some other file which isn't a cat part, the snap tool is what you'll want to be using. Okay, so I hope this has given you a bit of an insight into assembly design. Obviously, this is a very simple design. It gets a lot more complex with bigger assemblies, such as the UAV I've shown in my first video on this channel. But realistically, again, it's all to have a play with it. So this marks the end of the basics series. What will be happening now is I'll be moving on to a new series specifically on wing design. So I'll be showing you how to design it both in CAD, but I'll also have companions in terms of the technical ways or the technical aspects of designing a wing. So there'll be more solid modelling, there'll be more surface modelling, and there'll be more specifics to actually designing a wing. So if that does interest you, please do tune into that. As with any of my other videos, if you do have any questions or comments, please leave them down below and I'll try and get back to you. Do follow my Twitter feed, because I'll be starting something called the CAD Clinic, which will allow me to answer some questions you guys may have with a bespoke video. And yeah, please do check into any of my latest videos. So thanks for watching. Cheerio.